So hello guys, welcome to my channel, and you are listening to Komaltaya. So guys, so in the last video we talked about some commutator problems, the tricks that which I told you. Based on that we saw some previous year questions, right? So in case you haven't watched it, so see that, so you will be benefited only. Clear? So in this video I'm going to talk about very important properties without which, if I say that operator is completed, no, it is not completed, because if I don't cover them, so then the operator topic is incompleted. Clear? So I need to so I'll cover this linearity property and distributivity property, and you will see that these two properties only, these are so beneficial in solving questions. So that's it guys. So without delaying, so let's start our video. Clear? So let's see what is linearity property of operator. Clear? So this is one linearity. Clear? So commutator relation guys, it follows the linear relationship. Clear? So suppose if something is like this, suppose if something is in this form, x comma px plus px, so then how you will solve that? For that you will do it like this: a comma b. So first you will take this one, then you will take this one. Clearly, just take first two couples, like first couple, and then take the later couple. Clear? So it is a comma b, I'm taking a b, so that will become a comma b. Clear? And then plus is there, so I will write plus here. Simply I will write plus. Clear? So now I'm going to take another one like the second couple, that is a comma c, so I will simply write a comma c. Similarly with this one, suppose if there is another example, so what I'll do, I'll take this one and then I'll take this one. Clear? So this will become a comma b. Okay, a comma b, and then minus is there, so write minus, because there is minus, so you will write minus, and that will become, now c comma b is there, you will write c comma b. So guys, can you see how easy it is? Only you need to talk about the pairs, right? So in like suppose there are two entities on this side and two entities on this side also. So how to do that? Simply you will do it like this. First you will take a with c and then a with d. Clear? And then you will take b with c and b with d. Clear? So let's take a with c, that will become a comma c. If I take a with d, so minus is there already guys, so I will put minus first. I will put minus and then I'll write a comma d. Okay, so that is done. Clear? So what I'll do now, that I will take b and I will multiply it with another thing, whatever is present there. So let's multiply it and let's see what will happen here. Clear? So first b will be multiplied with c. First of all, please tell me. Obviously b will be multiplied with c and then it will be multiplied with d. So let's take it with c. So that will become plus, because already plus is there, so you will write plus and b comma c. Okay, so now you are going to take b and d. So now minus is there, plus and minus is there, so plus into minus, that would be minus. Clear? So minus will be there and that will become b comma d. I hope, and these properties guys, these are very important and these are usually helpful in when little bit higher level questions of operator comes for chemistry. Clear? So suppose guys, like that only, suppose if I have this position operator with this Hamiltonian operator. Guys, Hamiltonian operator means sum of kinetic energy and potential energy. In the very first lecture, I guess I told you that is sum of potential energy and kinetic energy. Clear? So now it is in this form. Can you see guys, it is in this form. Clear? So that is in form of a comma b plus c. So what I'll do, I'll take this with this now, and then I'll take x with vx now. Clear? So if I take x with kx, so that will become x comma kx, Clear? So then plus is there, so I will write plus. So now that will become x with, now I'm taking x with vx, so that will become x comma vx. So I hope that is clear to you. Let's move to another property, that is distributivity. Suppose guys, these type of things come in front of you, that x comma px square. So guys, I told you the trick, that okay, how to solve that. I told you that px is that later stage, so you will write plus I h squared, and whatever operator will be having power, that will be differentiated. So px is having power, so that will be differentiated. So I wrote that. Clear? But how to, like, the actual solution is what? That was trick. That was trick. So how to solve? What is the proof that I'm telling you truth? So let me show you the proof. The proof of this thing comes from this distributivity property. So according to it, you can write px square like this. Can you please tell me? Can you write px square like this? Px dot means, guys, multiplication. Clear? So it is similar like this, a comma b dot c. Clear? So how to solve that equation, how to solve such identity? So what you will do, guys, first you need to take that what are in pair. So guys, this px, like apart from comma is separating these operator. So here on the right side, can you see that px are pair? Px are pair because they are coming together. So here in this case also a comma bc, so this bc are in pair, so this will always come together, that b will come first and c will come later on. Always remember that whatever is in pair, that will be as it is. So what I'll do now, I will take pairs like that only, a with b and then a with c. So guys, if I take a with b, so that will become a comma b. Clear? So now point it, suppose if I'm writing over here, that is b, c. Suppose I am taking a with b and then a with c. So if I have taken a with b, clear? So I have written a comma b. So I don't know whether to write c over here on this side or on this side, like here or here. Clear? So what I'll do, that I'll check the pair. So bc is in pair. Just check for this one. Just search for this one, that what operators are in pair. So BC is in pair. Clear? So now BC is in pair. So what will happen now, that B will always come first and C will always come later on. So can you see that B has already appeared here? So B has already appeared here. So C will come here. So guys, I'm telling you trick to remember this. That B is coming at first, so C will come later on. So now plus, I will write plus and then I'll take another pair, that is A with C. So now I will write A comma C. So I have written A comma C. Clear? So now I'll see that BC is again pair. So I'm confused that I have written AC. So what about B? Whether I should write B over here or here, like at later stage or at first stage. So we can check for the pairs. So since BC is pair, so C has come at second position. So you will write B over here at first. Fine guys, because if you are writing B over here, so that will become that B is coming at second position. So that's how you will write it. So I hope you got the formula, like you got the trick how to write such things. So that will become A comma B C. That is similar like that only. Clear? So another form can also be there when the pair are in first position. When the pair are in first position, you can see the next example where AB comma C is there. So let's see what will happen in that case. So here it is AB comma C. AB comma C is there. So now again I'll take two things. So now can you see that AB is pair? AB is couple. They are coming together. Clear? So now again I'll do like this, A with C and B with C. Please tell me. That's what I'll do. Clear? So if I take A with C, so now point is where to write B. So guys, with A, so AB was pairs. So A will come first and B will come second. So if A is coming second, so I will write B as second. A is coming first, so I will write B after A. Clear? Now again I'll take this pair, that is A with C. So I have already taken with A with C. Now I will take B with C. Clear? B with C. So now I have taken B comma C. So now point is where to write A. Whether to write A over here or here. Clear? So now you know that A will come always before B according to this identity. A will come in this identity. A will come before B. So B is already appeared. So A will come obviously here. So guys, that is the identity. I hope this thing is clear to you and this thing seems easy to you. If you'll read again and again, so these things will be very easy for you and you won't be even taking time to understand them. I hope that is clear to you guys. So the next example is suppose here we talked about only two couples. Suppose if three things come simultaneously like that. So what you will do guys, you will take two things simultaneous. Suppose if I replace BC with M. Suppose if I replace BC with M, then it will become three things like that in the earlier case. Clear? So then you will do it accordingly like this case, like these cases. Clear? And then later on you can put the value of M. I hope this is clear to you. Just replace BC is equal to M, and then it will become A comma MD, and similarly we'll do like that, A with M and then A with D. Clear? MD are pairs together. Clear? MD are couples. Clear? So A comma B. So if I take A with M, so that will become A comma M, and D is at later on after M, so you will write D here. Plus now you will write A with D. So I will take A with D, and now D is at later on, so I will write M at first place. I hope this is clear to you. These are very easy, and just put the values at last and don't be confused in such things. These are very easy. Just do the practice and you will see the results. So let's talk about the example. Fine. So like how to solve. I told you the trick that the answer will come here. Suppose if I'm taking x comma px square, I told you that if px is at later stage, that will become plus ih cut, and it will become, and px will be differentiated because it is having power. So it is 2px. Clear? So guys, I can also write it like this. I can write it like this. X comma px square can be written like this. X comma px dot px. Fine. So let's do it according to our identity, what we have learnt. Clear? So can I write it A and B dot C? So first I'll take A with B, and then I'll take A with C. So if I take A with B, so that means I'm taking X with PX. Clear? So I will write X with PX. So first PX I have taken. So you know that this is couple. So another PX will come after this middle PX. Clear? So that is the case. Plus you will write A with C. So let's write with A with C. So that is A with C. So that will become X comma PX. X comma PX, this one. You are taking X with PX. Clear? So since you have taken PX at later stage, so this PX will come before this one. So let's write PX over here. It is similar to the identity where we discussed where just now we discussed it here. Clear? I hope this is clear to you. And you know guys that xpx is ih cut value. You know that xpx is ih cut value. So put the value of xpx, that is plus ih cut. So that will become px. Fine. So now what will come? So it will be px only. Px is same, and xpx is there. So xpx will become plus ih cut. Guys, it is same only. It is same only, like it is already written, and I just wrote this thing. Clear? So this xpx is plus ih cut. So can you see this is also plus ih cut px, and this is also plus ih cut px. So it will become 2 ih cut px. So it will become 2 ih cut px. I hope this thing is clear to you, right? So that's how you will solve these questions. So let's see for another one also, that how can you solve these questions like this also or not, by these identities. Suppose if px cube comes, so then what you will do? So this px cube will come, and you will be writing it like this. Px cube, can you write px cube like this? Px square dot px or px dot px square, anything you can write, you will get the same answer. Clear? So this will be x comma px square dot px. Clear? So now this is in form of this one, a comma b dot c. A comma b dot c. Clear? So now again that is the same identity. You will do like this, a with b and then a with c, and bc are couples. Clear? Suppose if I take this a with b and a with c, suppose if I'm taking this a with b means this x with px square, and then with this x with px. Clear? If you take with this x with px square, so you will write x comma px square, and this px is at later stage, so you will write at later stage. Plus what you will do now, you will take this one, x with px. X with px you will see, and that you will write x comma px, and now px is at first before px, so you will write px square. I hope that is clear to you. Clear? So what you will do now you will like suppose if you are going by this method, so you have to solve again and again to solve something. So always go by tricks. Clear? So don't do it by this method. I'm telling you for solution only. I'm telling you the proof of the thing which I told you. Clear? So don't follow these things. Clear? Don't follow these things for MCQ type questions. Clear? For subjective exam, obviously you have to do by this method only. Clear? But for MCQs type exams, clear, where MCQs come, you have to attempt question like that only. like this, like by tricks. Clear? So let's now, this case has this has become like this. Clear? So it will become x comma px square, you know, that is px is at later stage, so you will write plus ih cut, and this px square will become 2 px. So this px square will become this px, and another px is there, so that will become px square, like that. I'm telling you here so that it becomes clear to you. So this will become, so px is at later stage, so it will become plus ih cut. Clear? And then it will become 2px, because px is having power, so that will be differentiated. So when you will be putting it like this, when you will be putting it over here, it will become 2 ih cut, and px is there, so it will become px square. Same with this one, px square is there, and xpx, you know, the value of xpx is ih cut. Clear? So it will become plus ih cut px square, and it will become 2 ih cut px square. So you know that these things are same only, ih cut px square, ih cut px square. So you will be adding it, and it will become 3 ih cut px square. I hope this thing is clear to you. Clear? So that is the answer. Like suppose if you go by trick, the way I told you, so by trick it will become directly like this. Suppose x px cube is there, so px is at later stage, so it will become plus ih cut, and px is having power, so it will be differentiated. Guys, so answer will be same. Can you see the answer is coming same? The trick which I told you, I hope that will be beneficial. You can do it within seconds, and this will take very long. Clear? So don't do it like that in your semester exams, or like that. You can do it like this in your semester exams, or like that, where subjective type things are need to be done. Then you can do the questions like the way I'm telling by properties. Clear? Otherwise in exam, in entrance type of exam, you don't have to rely on such methods. I hope this thing is clear to you. Clear? So let's see some example. Let's solve some more examples. Let's revise some things. Clear? So you know that xpx, that is simply ih cut. You know that px is at coming later stage, so it will become plus ih cut. Now xpx square is there. Okay, xpx square is there, so you will write this like this. You will write this, so now px is at later stage, so you will write plus ih cut like this, plus ih cut, and this px will be differentiated because it is having power, so it will become 2px, 2 minus 1, that will become 2 ih cut px. Like this will be differentiated. Clear? And same with this one, x comma px cube. So now px is at later stage, so you will write ih cut, and it will become 3px, 3 minus 1, and it would be 3 ih cut px square. So guys, this is like, in that way it will go on. Like if any n value will come here, so n value means any value, 100 or 200, any value come, any random value come. So you should know that how to do that. You can do in the similar manner. Clear? So let's, without delaying, let's discuss more things, that what happens. Let's see the properties also, some important properties of operator. Clear? So guys, this thing I told you, that operator commute with itself and its power, like the way I told you that x comma x, that will be 0, and if x comma x square is there, that will also be 0, and any power will be 0. Clear? So commutator with same the operator with same operator, and commutator values asked, that would be 0, and same with anyone, px comma px, that would be 0, and px comma, in fact px comma px 100 is also there, that would also be 0. Clear? If same operator is there, so that will become 0. Clear? So that will become 0, and that is the case. Clear? So this identity, I hope this is clear to you. So let's come down to another identity, that is linear operator always commute with constant entity. So what is the meaning of this? That suppose if something like that come, x comma ih cut comes, and it is asked to you that what will be the value of that. So guys, suppose in this, suppose no operator is there here, because this ih cut is not operator, this is constant value. Suppose if it was like this, ih cut px, then it would have been like this, that you would be taking this ih cut outside, and you will be writing this xpx like this. Clear? But now no operator is there with ih cut, so any constant entity is there with x in commutator value, that would be 0. Like any operator with constant entity, that will commute. Commute means that value will be 0. I hope that is clear. You can write also, you can see also, a is constant here. So any operator with any constant value, the value will be 0. I hope that is clear to you. Clear? Also I showed it that how that value came 0, because you know that the commutator, suppose if AB AB psi is there, you write it like this, AB psi minus BA psi, because that is the definition of commutator. So that's what I wrote, that A and A, so I wrote AA psi minus the BA, so BA means A into A psi. Clear? So this A will, can I write this A like this, because constant is there, I can write it anywhere. Like operator, I can't shift the position of operator, but I can shift the position of constants. Clear? So I'm taking this A outside and it will become A psi minus A and A operator psi. So this will cancel out and it will be 0. I hope this thing is clear to you. Clear? So let's come down to one another. Yeah, it is same only, guys. Like that, if something is in multiplication like this, x into half kx square is there. X into half kx square is also there. So you know that half k is this one, half k is constant, so I'll be taking half k outside and it will be x comma x square. Clear? So x comma x square, you know that any operator with same operator is there, like whether if it is having power or not, that would be 0, so answer will be 0. So the meaning of this identity is this. I hope these things are clear to you. So let's see more thing that what will happen. Clear? Also, I need to tell you one more thing, guys, that partial derivative operator, they does not commute with position and its power if they both have same coordinate. Clear? Suppose, guys, if it is like this, d by dx comma x is there, so that would be non-equal to 0. Non-equal to 0 because you know that the value of that is 1. So 1, you know, that is non-equal to 0. Clear? So I hope that is clear to you. Suppose if del by del x comma another coordinate is there, that will be 0. With another coordinate it will be 0. Clear? With same coordinates it will be non-zero. Same with this one. If px is with another operator, that will be 0. And if it is with same operator, you know, with same operator it would be non-zero, and you know what is the value. Now px is at first, so it will be minus ih cut. You know the value. I hope that thing is clear to you. So it was easy only. It was easy identity only. Clear? So here I showed the proof that how it is 0. Like if you are taking px with another coordinate, so how that would be 0. So let me show it that how that would be 0. So let me tell you. So what you'll do, you'll try to prove it by this formula, that ab minus ba. So if it is if it commutes, so it should be 0. If it commute, so it should be ab minus ba is equal to 0. If it does not commute, if it doesn't, then ab minus ba will be non-equal to 0. Please tell me. I hope that is clear to you. Clear? So what I'll do now, I'll solve this. Clear? So px, so let's put the value of px first, that is minus ih cut del by del x comma y. So that is the value of this, that is it is minus ih cut. If I put it value, so if I solve it like here, so you know that is minus ih cut del by del x comma y. Clear? Comma y. Clear? So what I'll do, I'll take it outside because this is constant. Minus ih cut is constant, so I'll take it outside and it will become like this, del by del x comma psi. Guys, now two variables are there, x and y. So now I'll take wave function depending on two functions, x and y. I hope that is clear to you, that I will be taking two wave function with two coordinate, because here not only x is coming, y is also coming. Clear? So it will become like this and it will operate on any wave function, so it will appear like that. So that's what I have written over here. Clear? So that's what I have written over here. So let's solve it by commutator thing. So this a comma b is there, and you know the meaning of a comma b is ab minus ba, ab psi minus ba psi. Clear? So let's write it. Ab means this is A and this is B. So A means del by del x, so I have written del by del x, and B means y. So y is there and psi xy is there. Clear? So what will happen now? It is minus. Clear? So let's write minus, because AB psi, so I have written psi also, minus BA is there, so B is y now, so you will write y, and then A is there, that is del by del x, and that is del by del x. Clear? And then psi will be there, that is psi xy. Clear? So now I'm done with this thing now. Clear? So let's do one more thing, that let's simplify it more. So guys, one thing I need to tell you about partial differentiation. People who don't know about these things, I'm telling you that what is the basic difference between complete differentiation and partial differentiation. Clear? So guys, in complete differentiation, everything, if two variables are there, so they will be considered like both will be considered variables. Suppose if d by dx and xy is there, so you will do the differentiation like this, that you will take first one common and then you will take another one like that, and then you will add it, and then now you will take second one outside, the way I told you in that a square example. If you remember that in the last video I told you the a square example, where I told you that if two variables are there, you will differentiate it like this. Clear? But suppose partial differentiation is there, so you represent partial differentiation by this, del by del x, and x comma y is there. So guys, whatever is in denominator, you will only differentiate that only. So now x, like in denominator x is there, so you will only differentiate x and you will treat everything constant. So just take y outside and differentiate x only, that is d by dx like this, and this will be 1 and it will be y. Clear? Suppose if x, y, z was also there, suppose if x and it was x, y, z, so what you will do, that you will take y, z outside, because there in denominator x is there, you will only differentiate x. Whatever is in denominator, you will only differentiate that, so that will become del by del x, so answer would be yz. So I hope that thing is clear to you, the basic idea that how this complete differentiation and this partial differentiation works. And guys, you should know about that, because that is very much helpful in this all quantum mechanics, in fact. Clear? So that would be minus, so I have written minus I h cut, that was minus I h cut. So now x is in denominator, can you see? Now this is partial derivative, del by del x, so now x is in denominator, so I'll only differentiate x and I'll take everything constant. Clear? So now psi is depending on xy, so I'll take it inside only, because psi is also depending on x. Clear? But I'll take y outside, so let's take y outside, and this now psi is only one term, clear? So now you will be taking it like this only, psi xy. Clear? So that will become this psi minus y, this like that, minus y del by del x, and it will be as it is only. So guys, can you see these two things are similar only? Only it is plus and it is minus, so it will be cancel out and it will be 0. Clear? So it will be 0. So always take care of these things, that px with another variable, that would be 0. Clear? Px or any operator like that, x with y, this linear momentum and position operator with another operator, that would be 0. Clear? And also this one differentiation operator also with another operator, that would be 0. I hope that is clear to you. Just take care of these things, so everything will be easy. So that was the proof that how that is this one. So guys, this one also I need to tell you one more thing, that suppose if x comma p square come, so in exam I know that lot of you will be doing this mistake and you will be writing it answer like this. You will be writing, okay, p is at later stage, so I will write it like this, okay, p is at later stage, so I will write plus I h cut, you will write plus I h cut, and now p is having power, so I will write 2p. Don't do that, guys, don't do that. That is for same coordinate. Suppose if it was x like that, if it was x px square, then this answer was correct, but now p square is there, and in the very starting lecture I told you that p square is px square plus py square plus pz square. So let's elaborate it like that. So if I write this p square as px square plus py square plus pz square, it will become like this. Clear? So let's solve it by our basic properties which we have learned till now. So wait, I'll take this pair, then I'll take this pair, and then I'll take the third pair. Clear? So if I take x comma px square, I will write x comma px square plus, okay, plus is there. Clear? So plus, and then x, this second term you will take x comma py square. Clear? So now plus is there, so you will write plus, and another term, that is x with pz square, so you will write x with pz square. Suppose if x comma py is there, so that means they commute with different coordinate. Clear? With same operator they do not with same operator also like the position operator commute, like this one, xx commute with same one. Clear? But if px comma x come, then they do not commute with same coordinates. Clear? With same coordinates. So x comma py square, you know that is 0, because they are different coordinates. Clear? And this x comma pz square, they are again different coordinate, they will be 0. Clear? Guys, also I need to tell you that Lx, it is not true with angular momentum. I'll tell you another story. There will be another story for angular momentum. I'll discuss it later on in later lectures. Clear? So just stay here, that don't focus on L. This is for only px, x and d by dx. Clear? So what you will do, that with different coordinate it will be 0, and again it is x and z, so it will be 0, and but with same operator, with same coordinate, that is x comma px square. You know that how to write that. So px square, you know that px square, it will become, now px is at second stage, so that will become plus ih cut, that will become plus ih cut, and px square is there, so you will write 2px. Px square is there, so I told you that whatever operator will be having power, that will be differentiated. So now px square is having power, so you will write 2px. Clear? And everything else is 0, so answer would be ih cut 2px. Clear? So luckily guys, the answer is same only. Luckily the answer is same here. Like suppose if you would have thought it like this px also, then also your answer is plus ih cut 2px. But this can't be true in every case. Clear? So always do it like that. And in that case, if you do it like this, so you will never be trapped. So in that way, you'll never be trapped. So that's it for this one, guys. I hope everything is clear to you. So in next video, we are going to take some questions regarding whatever properties we have discussed today, like distributivity, linearity, and some previous year questions we are going to discuss in the next class. And also this angular momentum operator, that is so important from examination point of view, that if I want to give the question, definitely I'll choose angular momentum operator, because not everyone knows about angular momentum operator. Everybody knows about linear momentum or position or kinetic, but like very few people knows about this angular momentum operator, and examiner is nowadays giving questions from angular momentum operator. So in next class, I'm going to discuss some questions based on this whatever I have taught today, and some this angular momentum operator concept that we'll discuss in the next class. Clear? So link will be here somewhere, here the link will be there. Clear? So I'll see all of you in the next one. Till then, take care and keep smiling. Bye bye.